suppose we should start, right?
Yeah.
Only the faithful.
Only the faithful.
I only want the web people here. Okay. So if you love web, you're in the right session. Thank you for coming. And thank you very much for having me back to your island. It's a lovely place. I love speaking here. Amazing tech community, as well as a beautiful island. So today, we're going to be talking about web development. We're going to be talking about a little framework that I love called lit.html, and one of my big bugbears. Please come in. Please come in. Okay. So who on earth am I? Hi, I'm Mike. I think we can all agree that's a remarkable likeness of me. I'm a Google developer expert in web technologies. I'm not quite sure how that happened or what that means yet. I've been one for 2 years. I think it's predominantly because of the sheer number of hours I've spent apologizing for JavaScript. So, sorry. I work at a company called BVD Software Development based in Johannesburg. I work in the research and development team there, where I take care of some consulting to our clients, technology consulting, training. Please come in quietly. I should have waited. I should have listened. So I take care of some consulting, some training, teaching people how to build on the web better, and some industry-based research and development. I don't think I could succinctly explain what it is that I do on a day-to-day basis. But hey, they still pay my salary, so I think it's all working out. Not sure. I'm also the co-organizer of the Joburg JavaScript community. We meet on the third Thursday of every month, so if you're ever in and around Johannesburg at that point in time, ping me and you must come through. It's a super, super vibey atmosphere. But I think overwhelmingly, please come in, the most important thing that you need to know is that I am a web developer from Johannesburg with a reputation that has far too much coffee and is in a foreign context. Okay, so I'm probably going to speak really fast, and I apologize for that. I'm going to try and slow down, but you know what to expect. Okay. So what are we here to actually talk about? Well, we're here to talk about you. You as a person wanting to build for the web. Maybe you're fresh. Maybe you're in university and trying to figure out, well, what does web development look like? Maybe you've been in different parts of the industry, looking at back-end dev, server-side software, mobile apps, something like that, and you're trying to get back into web dev. Maybe you've just gotten into web dev, you've been in for a while, and it's still confusing, okay? And the reason why it's confusing is because everybody tells you, you just need the holy trinity. You just need HTML, JavaScript, and CSS, and everything else will be okay, right? Sounds like a familiar story. Except, you can't just write HTML anymore, right? You need to use a front-end framework. So you've got this plethora of front-end frameworks that you have to pick from, which everybody's got an opinion about, and every single one is very, very different. So you have to dig through that quagmire first and figure out, well, which one makes the most sense to you? Which one do you feel fits you best? And that invariably comes with its own way to do styling. So whether it's a post processor, whether it's a DSL language on top of it, whether it's CSS and JavaScript, you can't just write plain CSS anymore. And that's cool, but you also just can't write JavaScript because JavaScript is a brand owned by Oracle, by the way. I don't even know if I'm allowed to say that at a Google event. But it's a brand. That's not actually what it is that we write. We write typically ECMA script standard stuff, but you have a choice of either writing TypeScript or ECMA script. And once you made that choice, you have to say, okay, cool, well, ECMA script comes in a whole bunch of flavors, numbered by years. So you have to have an intimate understanding of which features you want to use and which year it was released in before you can figure out how to write your code. And like that's not enough. You then have to use tooling such as Babel to figure out which browsers I'm supporting and which browser versions I want to support and which versions of ES20 blah blah they support to generate tooling. And then, like, you can't just ship that to production. You have to use software such as Webpack or Rollup to bundle all of the stuff together so that you can actually get it onto a server somewhere. And you can't do this by hand. You have to use a server-side client library called Node or NPM to install your dependencies because there are so many dependencies. And this is how you end up with your Node modules folder being like 100,000 files and 2 gigs big. And you're like, but it's just a website. Why is it so hard? So if you're thinking, that this is too complicated, that this is too hard, and that this is too confusing, I totally agree with you. This was not the web that I fell in love with, and like, no wonder people hate it, right? Or all are afraid of it and find it confusing. So let's look at a better way, because we should just need to use the basic three: HTML, CSS, and JavaScript. Okay? It's unfortunately not as clean cut as that, because for very good reasons. We have to understand which version of JavaScript we're supporting. Now, luckily, we're in 2019, damn it. We can use the colloquial dataset of ES 2015 plus features, which means JavaScript that was standardized in ES 2015 and onwards, and that gives us a really solid sample point to work from. But I hear you say, what about browsers that don't support it? Well, I can guarantee you that every mobile device in this room, which should be your primary target audience, all of them support this feature set natively on their browser. Okay? 90% of your computers will support this, if not more. And if you're still supporting Internet Explorer 10, maybe that's a problem, right? Maybe you should get people to use a modern browser. And then unfortunately, you can't just open up an index.html page anymore. You can't just open up the document and expect it all to work. The web was designed to be served from servers, so we do need some server tooling. So Node is still in that ecosystem because we need a really low friction, lightweight dev server that's going to host our stuff during dev time. And then secondly, we don't want to download dependencies from the internet directly. We want package management, so NPM doesn't change. Okay. And then finally, you can't yet just write really smart dynamic updating HTML. I mean, you can, it's just really, really hard. There are very, very good modern primitives, which is WebComponents, which we're going to talk about quite a bit today, which let you create your own elements that are really smart and really infused. But updating the DOM, so literally creating the HTML and making sure that the HTML changes, is not something that the browser is good at the moment. It's coming, but for now, we're going to use something, which is a library that I like, called lit.html, that just does that. So what we're going to use today in the demo is we're going to use something called ES Dev Server, which is a simple dev server released by the Open Web Components Foundation. And it just does, well, it does a bunch of things, but it does two things that we care about. So firstly, it serves all of your static assets. And then secondly, it does something called bare module imports. Now, bare module imports say that when I import a file, I don't have to have the fully qualified path for that file. I can use the package name, like you would in Node.js, if that's familiar to anybody. And that's coming into the browser, but it's not there yet. Secondly, we're going to use lit.html, and lit.html is just going to do our actual template rendering, so generating the HTML for us. And we'll talk about that quite a bit. And then finally, we're going to use lit.element. Now, lit.element is just vanilla web components inside your browser, supported everywhere, with one additional change, and that's change detection. So it's the glue that binds the web component to lit.html and make sure that whenever one of your properties changes, it's going to re-render the page. Okay. And we get to use a little bit of magic that I call JavaScript to bind this all together in the darkness. So we're going to get into a whole long protracted demo. That's basically the end of my slides. But demos are inherently group exercises. I'm going to make typing mistakes because I haven't practiced on this lectern, and it's up to you to help me find them. Okay, so follow along. If you help me catch mistakes, there are some 3D printed chrome dinosaurs for you, and stress balls if you'd rather have a stress ball. Okay, so let's go. Let's get into this. So we're going to start off with a very simple project, an empty project where all I've done is install the Node modules because I wasn't sure if I could download packages with the internet at the conference, but the internet has been particularly good today. So this package.json just has some very, very simple stuff in it. It's got lit element and lit HTML, which I'm going to use later. It's got Open Web Components Dev Server. Oh, sorry, that wasn't supposed to be there. It's got a little bit of CSS just to make it look pretty, because you don't want to see me type horrible CSS all afternoon long. And then, as a dev dependency, it's got ES Dev Server, which is the thing we're actually going to use. And for that, we've created a simple start script, which is going to call ES Dev Server on this directory and pass in node resolve as an option, which is going to give us the bare module imports. That's the only tooling we've got. Okay. And I'm just going to go here, oopsie, to the console, and I'm just going to run npm start, which is going to open up our file. Now, we're going to need to create a website from scratch here. So obviously, a website always starts with our index.html page. And we're just very quickly going to scaffold up using Visual Studio Code, a little bit of HTML. Yeah, the defaults are fine. We're going to link our CSS. And we're going to link it to the node modules to do app-mvc index CSS. And we're going to go and write an H1 at the top just to show that it works. And bonjour, Maurice. I'm sorry for butchering your language. And if we now reload on this port, we'll see we've got a very, very simple index.html page. Okay, and that's great. I'm not going to bother about fixing that spelling, but this isn't what we're after. We're after something a little bit more dynamic than just HTML and CSS. So we're going to link to a separate JavaScript source file. So we're going to go script source JavaScript, and that's going to be app.js. And importantly, we're going to specify type equals module. Okay, and the reason why we specify type equals module is so that we can queue into that ES 2015 plus imports and exports and all of the good stuff. Okay, we're now going to create our app. Oopsie, not a folder. App.js. The one thing you can never practice in demos is the angle that you're going to be typing at. Okay, so in here we get to, for example's sake, just create some code. So we're going to say bonjour Maurice, here again. DevFest Mauritius, is that a thing? Is that right? Let's roll with it. Okay. And then we're going to have our hello. Now for our hello, the fundamental premise that this is all based on top of is something called JavaScript template literals, which is the backtick, and that lets us do something cool. It lets us interpolate between strings and JavaScript code. And we can do other cool things like evaluation. So we can say the time is now, and then jump into new date, and we're going to write some JavaScript .to locale time string, sorry, not date. Otherwise that's not going to update. Brackets, done. Okay, so now we've got a string that's got some dynamic bits in it, right? And we can just say document.body, which is the body of the document that we've created, .append, append, and we're going to append hello. Now when we reload the page, we can see that it updates every single time with the time, and it creates a string. Sorry if you can't see that. You're going to have to roll around. Now that's cool, but now we want to say, we want to put some more HTML elements in there. So if we wanted to create an H1, so that our hello was a big title, I'll close that, you'll see that it writes it as a literal string because it's not creating an HTML element, right? Unfortunately. For that, we need to do a little bit more. Let me just go to my app.js that I closed. So luckily, we get to do weird things like tag a template literal with a function, which is a weird DSL syntax that's been in there since 2015 that lets us do the following. We can define HTML as a function that takes in the static parts of a string and the dynamic parts of a string. Okay, so we know the parts that change and the parts that don't change. And then we can create a new element, document dot create element. We're going to create our H1. We're going to set the element dot inner text to, let's start off with the static parts. We're going to return that element. Oopsie. I haven't changed anything else, but now when we refresh, it's undefined. Yeah. Ah, haha! Who was that? Who was first? Can I throw it to you? Oh! I believe they bounce. If they don't, I'm sorry. Cool. So now we've got the static parts of that particular string printed to the page in an actual H1 element. And if we change to the dynamic parts, oopsie. Dynamic string. Yeah, it is string. It was supposed to be parts. Oops. It changes to the dynamic parts. Now, that's super laborious to do by hand, and that's literally what lit.html does for us. So I'm going to throw this away, and I'm going to import lit.html. So the HTML and a render method, which is going to take care of the rendering bits for us, from lit.html. And that lit.html part is the only thing we need the tooling for. Everything else that you see from here on in is native in the browser. Okay, so we can, our hello is the same, it's now using that HTML, and instead of appending directly, we can call render, passing in hello, and then put render onto the document.body, which says replace the document.body with hello. And now suddenly, we've got exactly what we expected inside our tag template string. Yeah, sure, go for it. Cool, but now we want to build something with it, right? Hello is all good and well, but we want to create a thing. So let's throw this away. We're going to create a to-do app, because that's the cool thing that we do, right? We create to-do apps? No? Okay, well, I'm going to create a to-do app. So let's say, assume we had a list of to-dos, okay? And I'm just going to throw some data in here. So we've got a whole bunch of to-dos on our list. Okay, we've got an app which, for purposes that'll seem clear later, I'm going to define as a function, and that is a function that's just going to return a little bit of HTML. Okay, and we're going to call that function here. Cool, and that HTML is going to be HTML that. It's just a section, class to do app, a header, and then a main class. Now inside here, we're going to have an unordered list of, just need to type this correctly, to-do list, ul.todo. Okay, and inside that, we're going to take our list of to-dos and we want to map them into a list of HTML elements. So that's actually pretty easy. It's just vanilla JavaScript. We can go to-dos.map, to-do, and then inside here, we're going to create a function called viewToDo and pass in the to-do that we've got. And then we're going to define our viewToDo up here. It's going to take in a to-do object, and then it's going to return HTML for us. Okay, and that HTML is going to be viewToDo. It's just going to be a list item with a div inside it, a checkbox, and a label, and inside that label, again, we can just break into normal template literal, to-do.title, and there we go. So if I refresh now, we should see a whole to-do application, which is pretty awesome, but we now want to add our own to-dos onto the list. Okay, so for that, we're going to do exactly the same. We're going to add a new let add to-do function, and that's going to return HTML, which is cool. That HTML is going to, HTML. See, I do say sorry so much. I think they're recording me. Oh, they are very literally recording me. Sorry. So it's just an input with a placeholder, and what we want to do is we want to bind onto the key up event. So we can just use the normal key up event, but to let lit.html know that this is now a specific thing that has to generate in a different way, we just prefix it with an @ Okay. Now inside here, I can just say, well, I'm going to pass you a JavaScript reference to handle add to do. Okay. And then I'm going to define that method up here. And in fact, I'm not going to do that. I'm going to generate the method, handle add to do. That's going to take in a click event, a key up event. If the key that is pushed is not enter, do nothing, just escape. Otherwise, it is enter, so we're done. Add our to-do onto the end of the array, set the value to nothing, and then call this update method. Okay. Now this update method that's going to re-render the UI, we technically already have at the bottom here. It is just our render method. So we can then define this as let updates equals a method that does that, and then we just need to call update on the initial page load to make sure that it's there. Now when we go to our application, I forgot to add it onto the header. Obviously, it's not going to be there. So I can go add to do, and then it's there. So there's a big text box at the top, and I can go, please work, and be very indignified and proud of myself when I've added a to-do onto the to-do item list. Okay, so that's all good and well, and this will actually get you pretty far. Like, we've got 54 lines of code here, which could probably be a little bit terser, and we've got a little bit of a thing going, right? So if you want to build small things, this is amazing, but I'm not going to stand and pretend that this is how you should be building big software systems or how you should be building controllably. We believe in ideas of encapsulation and isolation and separation and not having everything in one big file, right? So luckily, we get to create higher level primitives inside the browser. So we could take our app, and instead of just having it as a function, we could create a class app that extends a HTML element and create our own HTML element, but then we'd have to do the property binding and so on and so forth. So instead, we're going to create a lit element. Okay, extends lit element. So we can't import from lit HTML anymore. We're going to import from lit element. Our render method then goes away, and instead we have our lit element base class, which does our change detection and includes lit HTML in it. Okay, so we need a few things inside here. Okay, so the first thing that we need is we're going to need a constructor that we're going to put stuff in. We're going to call super, which is great, just so that it calls the base class. Then we're going to need a render method, and this render method is going to return some HTML. Then we need a properties array, so that's going to be a static get properties that's going to return just an object, return an object, and that object is going to have everything that, if that changes, is going to trigger a re-render. And then finally, because I really don't want to get into explaining CSS encapsulation and shadow DOM, and I want to use an external style sheet so I don't have to type out CSS, I'm going to disable the shadow DOM. If you're interested in CSS encapsulation, that's a whole nother talk, and we can discuss it a little bit later. But for the moment, I'm just going to create a render route that disables the shadow DOM. Okay. Now, that's all I need, and we're just going to move stuff from the outside to the inside. So if I go to my to-dos list over here, I can take my to-dos, and I'm just going to, in the constructor, put them onto this. When I create that to-dos list or update it, I want it to re-render. So that means I need to add it onto my properties. Okay, so that's going to cause a re-render. And then I can take my HTML, which is at the bottom, sorry, it's over here, cut it out there, put it into my render method, make sure that I'm referencing this .todos, and not everything's going to work precisely, but we're going to move it in bits and pieces, and then that's fine. But this update method no longer is relevant to us. What we're instead going to use is we're going to use a browser API called window.customelements.define. And we're going to define a custom element, which is to-do-app. All custom elements have to be hyphenated. I don't know why. Somebody liked hyphens. And we're going to pass in the reference to app. Now what that means is inside here, we can just scrap that and create an element just in HTML called to-do-app, right? And if I haven't mistyped something when I reload, it looks exactly the same, which is a good thing, thankfully. So we can carry on moving the rest of the stuff, okay? So let's start by doing the view stuff. So if we take our view stuff, we can go and create a new JavaScript file called view-todo.js. And I'm just going to scaffold out some stuff so that I don't have to type it all again. So it's view-to-do and view-to-do. Cool. Then this is going to take in a to-do. So we know it's going to be given a to-do object, which is just type object. And then we know we've got a little bit of HTML in here that we're then going to move across into our HTML render method over there. We need to change this to this dot to do because it's now in context of a class, so we're no longer referring to global variables everywhere. That's great. And now in the app class, all we have to do is import that, import view to do.js, oopsie, do.js. And over here, instead of calling the view to do method, we're going to generate an HTML element. So for that, we're going to generate it using lit HTML. Inside here, we're going to say, well, this is a view to do element. And for that view to do element, I'm going to pass in the to do object. And because I know this is going to change, I prefix it with a dot. And that just triggers that change detection stuff inside lit HTML. Okay? And then I'm going to pass in, breaking out into just JavaScript, the to do that I'm mapping. Okay? Now, if I go to the outside again and reload, yay, it still works. The last bit that's a little bit more complicated is the add functionality, because we need to add onto that array. So for that, we're going to start the exact same way, creating our add to do.js file. I'm going to scaffold out some stuff. Add to do, not tofu. That would be a disaster. Okay, we're going to move across our HTML, which is great. Move across our HTML into here. We don't really have any properties that are going to trigger a render change, but we do have is this handle to do method. So when we move handle to do across, we see that we hit a problem. Okay, and that problem is that we first take it from a fat arrow function to a normal instance method. Let's fix that, which is cool. We've got the key enter, which is fine, but now we have to have a reference to the to-dos array that exists on the other object. But now this is where encapsulation comes in, right? So if we want to be able to control that engagement, we need to pass in a callback to this component. So what we'll do is we'll create, or we'll assume that there's an add to do method. Everything else here stays exactly the same. We can get rid of the update stuff, and then we pass in add to do, and because it doesn't really matter, we're going to declare it as an object. Okay. And then inside our app, how we would use this is firstly we would import it, add to do.js. Then we would go to our add to do over here. We don't need JavaScript there. We would go to add to do, and then we would pass in a dot add to do, and then, and inside here, we would break into some JavaScript. And to keep context of this, I'm going to use anonymous functions here. I recommend doing that just because it keeps things a lot more reliable. Okay, we're going to call this dot add to do, and we're going to pass in e, except it's not actually e, it is to do. To do. Okay, and we're going to create this add to do method at the bottom here. Add to do. It's going to take in a to do. I get so bored of saying to do, and then we need to update this dot to dos. Now, it would be reasonable to assume that we could just push the new to do item onto the end of the array like that we were doing. But unfortunately, it doesn't work like that because it's very difficult without expensive change detection algorithms for JavaScript to figure out if the array has changed. So the most robust way to do it is using immutable-based design and just copying stuff. Now, luckily, we have a really cool syntax for copying. So we're going to create a new array, and we're just going to use the spread operator to copy the old items across. And that's enough to give us a brand new array and trigger change detection cheaply and quickly. Okay? And we can then just say, well, smash our to-do item on the end of that array. And this is great. When I refresh, oops, I forgot to add it. Did I forget to add it? What has gone wrong? Handle add to do is not defined. Oh, of course not. Of course not. this needs to be an anonymous function, remember? This dot handle add to do, and then pass through E. And I can shut that down. Yay! Does it still work? No, it does not. Add to do is not defined. Add to do at this dot add to do. Damn it! This is hard. Okay. Now it'll work. Now it will work. Yes, it worked. Whew. Okay. Not even any ironic applause. You're a very polite audience. Thank you. I bask in the adulation. All right, so just because I'm OCD, I'm quickly going to add the completing of to-do items, because otherwise we haven't actually achieved anything. But I'm going to go through that really quickly to show you a different way of shortcutting the event redirect. So inside here, what I get to do is just add a couple more things onto this checkbox that's going to toggle the completion. So this is toggle 1, okay? And that's going to be whether the checkbox is checked or not, and that the attribute needs to be added or removed based off of whether the to-do is completed or not. So we use question mark for that, so the whole attribute gets removed. There's a click event again, which is going to call this.toggle completed. But instead of using a function here, I'm just going to pass in toggle completed in our properties. Okay. Toggle 2, which is just toggle completed like that. And then on the outside here, we then need to, sorry, it's not here. It's at the bottom. We then need to add toggle completed, toggle 3, which is just going to be the exact same model as we saw before. So we don't have an implementation in the component, it's just passing the to-do back up. And then at the bottom here, the only slightly complicated thing, remember because we have to use the immutable copying of stuff, is our copying of that item. So this code looks a little bit funky, but we're taking the to-dos array, we're mapping the to-dos array, and if it's the exact same item, or if it's not the same item, just return it. We don't care. Don't influence it. But if it is the same item, copy its properties across and toggle the completed flag. Make sense? Okay, awesome. And that, if I'm unmistaken, will now firstly show us that we've got everything working and we can mark everything as done. Yay, profit. Woo! Now, in summary, just to close off. Hacker time. So in summary, it can, and it really should be easier than it is at the moment. We shouldn't need complicated tool chains and type systems and transpilers to be able to make this work. And in future, we won't need to. It doesn't have to be what I showed you here. This works for me. It's as close to the platform as I feel comfortable with enough of the leverage that I feel that I need. You use whatever you feel like, okay? But just keep that minimalist perspective in mind. Keep it simple. Use the platform, understand what it can do for you, and understand what your constraints actually are. Okay. And if you have that awkward user that has to use IE10, maybe educating them is the best option for you. Okay. So if you have any questions, please hit me up. I've still got some dynos to give away. One last thing before the question. I talk on this and related topics quite a bit. You can go and visit that URL to see some of the talks that I've done in South Africa and around. And lit.html has really good documentation, and it's super, super minimalist. At that point in time, I'll take your questions. Yes?
Can you just explain maybe the difference between using the dot and the at in front of it?
Cool. So the reason why that's necessary is because the lit project had a choice to make. They could either include like non-trivial change detection algorithm stuff like Angular does to figure out what you're sending it and what it needs to do with that. Or they could say, well, just add additional syntax and you tell it what it needs to do. And that's where those characters come in, which just prefix whatever the attribute is. So the dot implies that it's a property that needs to be watched. You can still pass in the property. So on the function, I didn't technically need the dot in front of it. You can just pass in a property and it's a static property. It'll never update. Lit.html will never re-render if that changes. If you pass a dot on it, it will re-render. The @ is an event saying that this is a thing that I need to watch for DOM events for, because it's abstracting the DOM layer, right? And then the question mark is the conditional adding, and that's it. Like those are all of the Mystic incantations you need to get this working. You can write directives, you can write pipes, you can do sophisticated things if you want, and all you need to do that is write JavaScript. Do you want a dyno or a stress? Both. That was a simple enough answer.
If you don't ask, you don't.
Yep. Who else? Yes.
How big is it?
Lit is 3.5 kilobytes. Angular default, like if you don't do anything, you just ng-new install, what it generates like 4 megs of JavaScript, right?
Okay, what do you do for backend requests?
Backend requests, you use the fetch API. The fetch API is a browser standard API that works exactly the way that you would expect. It's promise-based, it's exceptional. I'm not lying when I say you don't need an HTTP library in your front-end application. I just run with that on a production application myself.
How big apps you build with that?
How big? Really big. This is, I add one additional thing on top of this. For big apps, I use something called Redux. I don't know if that's familiar to anybody in the room, to do state management, because state management is hard. And Redux is what, like 5K? So 5 kilobytes of Redux, 3.5 kilobytes of lit HTML, and that's the baseline of my progressive web app. So if you come to my talk later this afternoon on PWAs, I'm going to be showing something built on React, but this is how I build my PWAs. Okay, so I dog food this stuff, I promise you.
Any like commercial app that you built using this technology?
Yeah. This.
Oh, this.
Yeah.
Okay.
I'll take it down.
Take it down. Yeah. So yes, I run a production site, a commercial application for my business that we've built using this stack and Redux. That's the one that I'm talking about. So I believe it. Like I promise you, I'm not exaggerating. We have added. So from a build complexity perspective, we've added one additional thing, and that's Webpack, which sucks. I hate it. And the only reason we've added Webpack is because dynamic imports, so lazy loading of modules, isn't supported inside Firefox reliably yet. As soon as it hits Firefox, we're taking out Webpack, and we're just using vanilla JavaScript all the way up and down. You know, you don't need to change your code if you're writing very little code. Like 50 lines of code is not kilobytes worth of JavaScript.
How quick can you learn with HTML for the full-scale project?
Well, it depends on what you mean by full scale, because the things that are going to be hard about a full scale project is the project. Lit HTML is literally what I've shown you. With Spring Boot?
Yeah.
So what you would do then, so if you're using Spring Boot, are you using Spring Boot as an API, or do you want to render HTML with it? Sorry?
For API and workflow.
Okay, that's fine. That's completely okay. I use Express behind my production system, but I haven't used Spring Boot with this, but Spring Boot with just the API layer will work exactly the same way. You use the fetch API, which if you want, I can show, whoever wants, I can show you the fetch API after the session, and that's literally all you need. It works, does everything that you need it to. Okay.
Have you used any of the language frameworks that you showed in the beginning, React, Angular?
Yep.
So, in your experience, has there been any situation where Angular or React has performed or has been better to work with rather than with? In which kind of situation is it that they have the edge?
Okay. So, right. If you're prepared to do it all yourself, all of it, lit HTML and the platform is far superior in my opinion. But if you want a community of stuff behind you, and you want to not figure out how routing works in a browser, use React and React Router. If you've got a team that you want to generate static types off of, and you want TypeScript and good TypeScript support, and you're going to work in like a corporate environment behind the firewall, no public stuff, then Angular is great. It's good for teams, and it makes Java developers comfortable for some reason. So, I mean, if they're going to write better code because they've got types, then go for it. I don't feel like it makes a concrete difference, but that's their perspective. Vue sits in this weird middle ground at the moment that I'm not really sure of. It's neither one nor the other. It's not minimalist, and it's not a full soup to nuts framework like Angular. Use what makes you happy. whatever you think is great. If you've got React skill, that's amazing. Just keep in mind that don't ignore the platform, because when you become a framework developer, you're doomed to become one of these guys. Right? No, you are, because on a long enough timeline, I promise you, React 15 looks nothing like React 0.1 did. It doesn't work the same. So in a long enough timeline, you're going to need to stay up to date, and your frameworks will become extinct. AngularJS versus Angular, and Angular will also die. So stay to the platform, figure out what the foundation is, and that's all I'm really saying. You don't have to use this, just keep it as simple as possible.
One final thing is, since I'm guessing you've been working with this for a long time, at least, so do you know of any like starter kit, starter project that already prepares the components and the
Yes, I do. And we're going off script. PWA starter kit. It's got some rough edges. It's not perfect, but it is pretty damn good. Go and clone this repo, and it'll give you a relatively decent progressive web app with some Polymer tooling in it, which I'm not crazy about. It's not completely native, but it'll give you a very good idea of how to set up lit HTML, lit element, Redux, all of it. This is what we use to scaffold out my production system, for example's sake. Okay. Should have included that in the slides, sorry. But understand the baseline. Any other questions? So there's for you and you. No more stress balls, unfortunately. Sorry. And if there are no other questions? No? Yes?
Have you migrated any like existing projects? So you went away like Vue.js or Angular and then you decided, okay, now I'm going to migrate that to...
That's a great question. And the nice thing about lit HTML, right, is that it's so small, it's smaller than some of the components that you're using in your application, right? And it's got a very clear boundary using web components that works well inside other frameworks. So if you've got an Angular or a Vue or a React or AngularJS or anything that supports web components, I think AngularJS and React don't support it super well, but like Angular really does. They treat it as a first-class citizen. You can take components written inside lit element and literally include it inside your Angular app, and the change detection and everything will work as it stands. Like it'll look like it's a native Angular component. And that's because they respect web components, being the Angular team. React a little bit less so, because React does some weird DOM diffing, and it's that difference that doesn't work well with web components. And if you ever see like web platform obnoxious people like me that are unhappy with React developers, that's probably why. But yeah, have I done it? No. Can you do it? Yes. Should you do it? Probably. For big corporate systems, the shared code, like the calendar picker that we've all built, the notifications and pop-ups or menu bars that are across your whole organization, those can and should be web components like this, because then it doesn't matter what your product teams are building their apps in. If they use Vue, they can use the component. Angular, use the component. Server-side rendered, use the component. Doesn't matter. So all of the big organizations, really big, Netflix, EA, Amazon, Google, GitHub, they're all using web components for that exact reason.
So is a bunch of components for lit already?
There are, and it's not for lit, right? Because lit is just a rendering library that goes inside web components. I think you can look at webcomponents.org, webcomponents.org. I've added a space there. Yeah. And there's, like, this is all web components that work exceptionally well, supported. If you come from a Java world, Varden, it's a Java thing, right? It's a Java thing. Varden makes exceptional web components for Java ecosystem stuff. So take a look at that. Okay, cool. Well, I'll be around. If you're keen on building progressive web apps or what that means or what offline means, come to my talk later this afternoon. It's the last one. I'll try and hype down the coffee. I'm not going to lie. Awesome. Thank you very much.